morning, students. Mathematics 11. I am Mrs. Nell, as you can see, and we will work through the slideshow containing the information for the assignment and for all the exam papers. You will see that mathematics, you can't say I'm only going to study, for example, numbers. Everything will be in your papers and will be in your assignment. Right, so there you see my name. There are always numbers, and know your numbers. What are the natural numbers, your whole numbers, rational numbers? There are examples of those things as well. And the irrational numbers, for example, pi and roots and 2,71828. It never stops, it's carrying on and on. So study your numbers. It's in all the papers. And then we get transformations. In this case, I got the example of enlargement from a small bug to a bigger one. And there are always 3 marks. The first one is that you have to say this is enlargement, but it can be a smaller picture as well. And then you always have to say the position of the center of enlargement, and you have to work out the scale factor of enlargement. But sometimes it can be smaller as well. For example, in this case, we have a triangle ABC and a bigger one. How to find the scale factor and the center of enlargement? What do? We draw lines from A to the next A, and from B to the next B, and C to C. And where all the 3 points are meeting, this is the center of enlargement. And then we can always work out the scale factor. In this case, it is 4 divided by 2, so the scale factor is 2. If it's a smaller picture, it will be -2. There we have transformations that we can work out onto the images B, C, and D. From A onto B, this is enlargement. The scale factor in this case is 3, and the center of enlargement is the point where the 3 points will be meeting when you draw your lines with your pencil. They will meet at -7 and -7. The first -7 is for your x value, and the second one is for your y value. Right, there you see the solutions. And when you have A onto C, it is a rotation of 180 degrees, and the point is 0 and -6. And from A that maps onto D, it is reflection, and it reflects in the line y is equal to 0. Right, so you can look at your solutions, how we can find this. This is all in all the papers. How do we add and subtract expressions? If we had to add the following expression, we put all the x square values together. We add those, and then we add all the x values and all the numbers, and we leave the answer as it is, -5x squared plus 3x. When we subtract the first equation from the second one, there you see it. First we put the second one and subtract. Then we have 11 squared x squared minus 9x minus 12 minus 6x squared plus 5x minus 3. You add or subtract, in this case, your x squared values, your x values, and your numbers. The note, the sign changes due to multiplication by -1. Then we have the laws of indices and their applications. Number 1, if we have a to the power m times a to the power n, then we add the indices, so m plus n. Number 2, if you have a to the power m divided by a to the power n, then we subtract the indices. So it's a to the power m minus n. Multiplication, then we say m times n. If we have a to the power m times b to the power m, then we say a times b in brackets to the power m. Here the bases are different. And when we divide, then we have a to the power m divided by b to the power m. That's in brackets a over b to the power m. Then the indices are the same. So study your laws. It will not be given in the exams or in the assignment. In the assignment you can look it up. So these laws make our work with indices quick and easy. We apply a law rather than to work from basic principles. So we learn them off by heart. Right, there are some examples. 2 to the power 7 times 2 to the power 3, we add the indices. So it will be 2 to the power 10. The same with p to the power 9 times p to the power 1. If there's nothing, it's to the power 1. Then we add, so p to the power 10. The same with division. We now subtract the indices. So we can generalize this stating. So the root of a, m, and then you can look at the next one. The examples will be easier. Simplify the following. Number 1, 1000 to the power 2/3 will be the third root of 1000 in brackets to the power 2. You can work it out with your calculator and you will see it's 10 to the power 2. Number 2, that's a very valid law that you can study. 4 to the power negative a half will be 1 over 4 to the power half. 1/2. Now it's positive. It's much easier to work with positive values. So it's the same as 1 over the root of 4, and we know the root of 4 is 2. Number 3, 25 to the power 3 over 2. It's the same as, in brackets, the root of 25 to the power 3. So it is 5 to the power 3, which is 125. Number 4, we know the rule. Now it is 1 over 25 to the power 3 over 2, which is positive. The same as 1 over 5 to the power 3. So the final answer, 1 over 125. Number 5, 4x squared in brackets to the power 3 over 2. We can multiply and we see the indices. Then we see 4 to the power 3 over 2 times x to the power 2 times 3 over 2. Which is, in brackets, the root of 4 to the power 3. And times it with x to the power 3. The answer, 8x to the power 3. So we just use our laws. Then we have angles in polygons and circles. We know that polygons are flat shapes with 3 or more straight sides. And we must learn this. Triangle, we know it's 3 sides, 3 angles. Quadrilateral, 4 sides. Pentagon, 5. Hexagon, 6. And the octagon, 8 sides. A regular polygon has equal sides and angles. For example, a square is a regular polygon with 4 sides and 4 90 degrees angles. The interior angles of a polygon, interior, inside. Look at the following method for finding the sum of the interior angles of a polygon. The interior angles in this polygon are shaded. There you see it. The sum of the interior angles is 180 degrees. If you explain it to the learners, you can draw a triangle, or each learner can draw a triangle. And then they take the triangles angles. they tear off the 3 angles. And when they put it down on a paper next to each other, they will see it is 180 degrees straight line. So that's nice for the learners to do that, and they will never forget it again. If it's regular, we can divide by 3 angles, so each angle will be 60 degrees. We can see that when we have a quadrilateral, we can divide it in 2 triangles. So the sum of the interior angles will be 180 degrees times 2, which is 360 degrees. And each angle in a regular polygon will be 90 degrees. If there are 5 sides of the pentagon, they can draw the lines and they will see it is 3 triangles. So 180 times 3. And the interior angles of the regular polygon divided by 5, so 108 degrees for each angle. So the interior angles of a polygon with n sides, the sum of the interior angles will be, in brackets, n minus 2 times 180. So that you also must learn to remember if you have to work out the interior angles of the polygon. Then, in circles, the first one, the angle in a semicircle is 90 degrees. So, if you have AB going through the center of the circle, the angle on the side of the circle will be, in this case, P, and it will be 90 degrees. So, angle APB will be 90. The second one, the angle between a radius and a tangent is 90 degrees. So it goes through the center and to the line just touching the circle. We call that the tangent, is 90 degrees. So those 2 angles are equal, OPA and the angle OPB. Third one that you have to learn, tangents to a circle drawn from the same point outside the circle are equal. If you have the center O and A and B on the sides of the circle, when they come from the same point, in this case P, AP is equal to BP. That makes each angle at A, so angle OAP, as well as angle OBP, 90 degrees. Right, very valid to study this. There are examples. When you get something like this, always fill in what you know. Everything. You can work on your sketch, on your question paper. You work it and fill in every single value that you know. They must give you something. So angle P is 54 degrees. Then you can fill in the rest that you know. And sometimes it is also asked to say what is the reason why you say, for example, an angle is 90 degrees. So study this, how we can state this. And the learners must also learn this. Then there's some idea of tessellations. The learners like doing this, drawing the triangles, color it in, drawing circles, working with a pair of compasses. They like it very much. And color it in or fold it or make some, for example, butterflies. Then we can write equations and then we can solve it. For example, there is a long sentence. A certain number is doubled, then 7 is added. The sum is equal to 37. Find that number. In mathematics, we can write it very short. 2x plus 7 is equal to 37. We find 2x, it's equal to 30, so 1x is 15. And we must always write down the correct answer, the number is 15. Number 2, here we have 3 friends that are in a shop and what they spent. The first one X, the next one twice, and the third one spends twice as much as Charles does. Altogether they spent 105 Namibian dollars. How much did they spend? So let's make it x. So the first one is x plus 2x plus 4x. And that is equal to 105. So 7x is 105, so 1x is 15. The first one spends 15, the second one 30, and the third one 60 Namibian dollars. Number 3, find the value of x. We see that this is a straight line. So all the angles together will add up to 180 degrees. So x plus 20 plus 40 plus x is equal to 180. And we add the like terms. Then we see that 2x is 120, so 1x is 60 degrees. Then we have function equations in general. A function is a rule or formula that represents the relation between two variables and quantities. Many quantities in everyday life are related, and this relation can be stated in a rule or as a formula. So study your formula. The area of a circle is related to the radius of the circle. We can write down this relation as a formula. Area is equal to pi radius square. So in this case, we can work out all the areas of A, B, and C using your calculator. Pi radius square. Then we must remember the value of the independent variable, in this case the radius, is given or can be chosen. It is then used to work out the value of the dependent variable, in this case the area. Number 2 is the amount of VAT. Value added tax is related to the price of an article. So the VAT is a function of the price of an article. We can write down a function equation to find VAT at a rate of 15%. They must give you the rate because it's not always the same, and different countries have different VAT percentages. So T is equal to 15 over 100 times P, where T is the amount of VAT and P is the price. So here we see the price. It is 4,780. So T is equal to 15 divided by 100, because it's 15%, times 4,780, and that is equal to 717. In this function, the price, P, is the independent variable and the amount of VAT, T, is the dependent variable, because the amount of VAT depends on the price. Now, this is always nice, drawing and interpreting straight line graphs. We know that there are different types of graphs. Straight line graph, example, the equation is given. Y is equal to 2x minus 1. Complete the table of values. And we start from minus 2 for the x values up to 3. Then we must find it by putting in the equation in the x values place every time the value that is given to find y. There is the solution. If you don't know how to do it, you can look at that. Then we have all the values for x and y. Number B at the bottom, use your graph paper to draw a system of axes. Label the axes x and y always. Plot the points accurately. Use a ruler to join them, a ruler, not a pen, to form a straight line. Remember to use a sharp pencil. Label your graph always with the equation of the line. In this case, y is equal to 2x minus 1. And draw the straight line graph across the whole page as shown. Right, so there you see it. Your x and y values, the distances between 0 and 1 and 1 and 2 and 2 and 3 must be the same. I see students are using different intervals. It must be the same distance, always. So look at it. It must be neat. For neatness you also get marks. And you draw your graph over the whole page and you label it. You label also your y-axis and your x-axis. Right, there you see how it should be done. There are the points that are plotted and they are combined with a sharp pencil and a ruler. Okay, now we are here with the frequency table shows the scores obtained when a die was rolled. The score on the die, on a dice as we call it, there we have up to 6. And the times that they were rolled is the frequency. So there we see that. And the F times the X, frequency times the score. We work that out to get the sum. So we have the total is the frequency, we have the sum. Then we can draw a bar graph to represent the data. There you see it, very neatly done. The scores on the die. And then number B, find the mean and the median and the mode of the distribution. To find the mean, we have to find the total sum of all the scores. So the total sum of the scores is 158. And then we divide it by the frequency, which is 41. And you can work it out with your calculator. The median is the middle score. So the score above which half the scores fall and below which half the scores fall. So there were 41 scores, so therefore the median, the middle, is the 21st score. We arrange the scores from the lowest to the highest, and the scores are already arranged in that order in the frequency table. There are 4 ones, 6 twos, 5 threes. This gives us a total of 15 scores, and there are 11 fours. So we add these to the 15 scores. Now we have 24 scores together. This means that the 21st score is a 4. So that's why we say the median is a 4. The mode is the score that occurs the most often. We also can say it has the highest frequency. So the highest frequency is 4. Alright, the mean, you must concentrate on the mean. That's where the students make the most mistakes. Bearings, it always starts from north. And we always go clockwise. So from north to east, to south to west, and from west back to north. Alright, we work with straight lines from a point. The example, the diagram shows the different directions in which 4 learners are walking. Write down the bearing for each one. Asser, there you see where Asser is walking. 40 degrees. So we write it 040 degrees. And Bertha, 145 degrees. Carl is walking. We add up all of them, 40 plus 145 plus the rest. So that is 200. And Doreen, 310. Using a protractor to find or draw bearings. The angle, when it is smaller than 180 degrees, then we start from north and we go down to B and C. Make sure you always have your protractor with you. Pair of compasses, protractor, very important in the exams. If you have angles at B greater than 180 degrees, we always start with north again and we go south, which is 180 degrees, and then we add the rest that is needed. Very accurately you must work with this. How do we find an unknown angle in a right angle triangle? For example, Number 1, a ladder reaches 8 meters up a wall and the foot of the ladder is 6,2 meters from the wall as shown in the diagram. If there are no diagrams given, then you draw your own picture. Find the size of the angle theta between the foot of the ladder and the ground. In this case we know it is tan theta, so opposite divided by adjacent, 8 divided by 6,2, and now you must know your calculator to work this out. And if you have your answer, look whether it is possible that the answer could be 52,2 degrees. If it's a big number like 196 degrees, then you must know there's something wrong. So test your answer or decide what could it be possibly be. Number 2, again we can work that out. If there is an angle of 90 degrees and we have to work out the other side, then we can also use Pythagoras. Then we don't have to, but this is now the angles that we have to work out. But if we need to work out the sides, we can use Pythagoras. Here we know that we must know Sukatwa, which one is the opposite adjacent angle, and so on, or side. The volumes of prisms, these formula you must study. It is not given in the exams. In the assignment you can still look it up, but for the exams you must know it. The volume of a cube is side times side times side. The volume of a cuboid is the length times the breadth times the height. And for a cylinder, it is pi radius square, which is the base, the area of the base, times the height. And the prism, you find the area of the base and times it with the height. Probability. We can work out the probability of an event happening by using the formula. Probability is an event happening is the number of desired outcomes over the total number of outcomes. The second one, the probability of an event where the outcome is certain, it is always 1. Number 3, the probability of an event that is impossible, it is 0. And the probability of an event not occurring, it is 1, subtract the probability of the event occurring. There are some examples how we can work that out. It's not difficult. If you hear the word probability, you might think it's difficult, but it's not. Just make sense of what is given. Okay, that's number 1. A die again. Number 2, a letter of the word Okakarara is picked at random. What is the probability that it is a K? Okay, then we count all the Ks and we see there are 2 Ks and the total number of outcomes is 9 letters. Right, so 2 over 9. Leave it like that, don't work it out, just leave it as 2 over 9. Right, so there are some more examples. To solve a quadratic equation, we must rearrange the equation in the correct form. Ax squared plus bx plus c, which is 0. And then we factorize and we solve the resultant linear equations. And each one is equal to 0. This is always nice to work this out. Very nice. So look at the examples and work it out. Factorize. And then either x is equal to, for example in number 2, either x is equal to 3 or x is equal to -2. Let us summarize the properties of the quadratic graph, the parabola. There you see the parabolas. Ax squared plus bx plus c. Number 2, if it has a minimum value at its turning point, then a is positive. So it's, for example, plus 2 or 6 or 10 or 200. If a is less than 0, for example, -6 or -10, then it is turning with a maximum value. The turning point has a maximum value if you have your axis of symmetry. Right? How do we use a parabola to solve equations? Go through this as well. There's your graph neatly drawn, and you read it off from your graph. It's not difficult. It seems to be difficult, but it's really not difficult. Go through your examples. And there are the solutions. Number 2, you can draw a graph and find the roots. Use your graph to solve the equation on the same system of axes. Draw the graph of a straight line, and then you can solve it by seeing where the parabola and the straight line graph are on the same point. Okay, there we see the solution with the points that we have to plot. And if you look at the answer, there you see your graph. It has a maximum turning point, and you work on your graph to read off the values, as you can see. Okay, there are the table of meanings of thinking required, but in mathematics we don't always need all these different words. But we know that in mathematics every single sum is different from the previous one. There are the verbs analyze or calculate, comment, compare two things, the contrast, the difference between the two. Criticize we don't really do in mathematics. Deduce, define, demonstrate. For example, if you have to draw graphs, you must demonstrate. You can describe how you've worked out the answer. Determine the values, discuss or distinguish. Differentiate. In mathematics we have differentiation, but not for now. We can estimate. We must always estimate our answers. Is it more or less correct? Evaluate, or you must explain how you are going to explain to your learners. Find the answer. Identity. Illustrate, for example, graphs. Interpret your bar graph, for example. Investigate or list. Outline or predict what your answer will be. Relate or summarize. Write an essay. That you will never do in mathematics. You will not have to write an essay. Mathematics is as short as possible. Right, to conclude, we know we must learn our rules, our laws and formula. And we study everything. Nothing is left out. Everything in your syllabus will also be in your assignment as well as in your exams. Good luck. I hope it will go well. Start early with your assignment and do it neatly and correctly on the question paper.